So we were at DC motor principle. You all are aware that the principle of DC motor is which principle it is? It is Fleming's left hand rule. So we will not go into the details of this and directly we will start. But as you know that 8051 microcontroller, the current capability is in milliamperes. Maximum you may get 10 milliampere or so, which is not sufficient to drive any motor. So to increase the current capability of this and to interface the DC motor effectively with microcontroller, we have to go with some drivers in between 8051 microcontroller and motor. Previously, we used to use transistors as drivers, but we have L293D. This IC is 16-pin IC and it is especially used for motor, all types of motor drivers. What this has, this IC is having 4 pairs of non-inverting drivers like input 1, output 1 and ground is one pair, input 2, output 2 and ground is another pair, input 3, output 3 and ground is third pair, input 4, output 4 and ground is fourth pair. This is having two supplies VS. VS is for motor power supply because 8051 microcontroller works on 5 volt but DC motors can be 12 volt motors. It can be any voltage motors 24 volt, 36 volt etc. So this VS can maximum go from 5 volt to 36 volts. So this is basically for motor power supply. We have one pin VSS. This is for the internal supply and which is again connected with the microcontroller. So when we interface L293D with 8051 microcontroller, generally we connect VSS to 5 volt with pull-ups of 10 kilo ohms. Now when we have to interface DC motor, because you all know that DC motor is having only two terminals. One is positive supply, one is negative supply. So for these two terminals, only two pins of these drivers are, only two pairs of these drivers are sufficient. Why we use this driver? Because already we have seen that the current capability of 8051 microcontroller is not sufficient to drive the motor efficiently. So what this driver does? This driver is able to, each pair is able to supply you the current source or sink current of 600 milliampere and maximum peak current is 1.2 ampere. So with this, now suppose if I have to connect DC motor with 8051 microcontroller, because we have two pins of DC motor, one for positive supply, one for negative supply. So we will be needing two drivers from this IC. Let's say we take two drivers as input 1, output 1 and ground, input 2, output 2 and ground. So what we can do, we can connect two pins of any ports. Let's say here we have taken port 1. So we will take pin 0 of port 1 and pin 1 of port 1 for these two pins of DC motor. So from here it will go to input 1 and input 2 of L293 motor driver IC. And because this particular pairs input 1, output 1 ground, input 2, output 2 ground, this is enabled only when enable 1 pin is activated. It's been given supply. And to activate the other pairs of inputs drivers, input 3, output 3, input 4, output 4, we have to use enable 2. So now here only we are considering this part of these drivers. So we will be connecting enable 1 to plus 5 volt with a pull-up of 10K. And these inputs are also connected to plus 5 volt with a pull-up of 10K. So whatever signal we can give from here, this will, you know that microcontroller supply is plus 5 volt. So maximum level of input voltage will be plus 5 volt. So if we put logic 1, it will be plus 5 volt. If we put logic 0, it will be 0 volt. Now After enhancing the current capability, this is given to the motor. So input 1 is subsequently output 1 and input 2 is subsequently output 2. These two pins are connected to the DC motor. We all know the direction control of this DC motor, because DC motor is having two pins. This may be positive and this may be negative. So if positive supply is connected to positive and negative supply is connected to negative, it will move in forward direction. But if we reverse the supply, it will move in reverse direction. So the direction control can be done just by reversing the polarities of the supply to this DC motor. Now, how it is done with this 8051 programming, we'll see that. Is it clear to you? This one, L293D. So this is our schematic. We are considering port 1. You can use any port. Port 0, port 2, port 3, and it is also not compulsory that you have to use only port 1 pin 0, port 1 pin 1. You can use any two pins of this particular port. So here in this particular example we have considered port 1, and for port 1 we have considered the pin 1.0, pin 1.1, and these rest pins we have not used. So we are considering only these two pins for microcontroller interfacing. So when we talk about direction control of a DC motor, what is our job? As we have already explained that we can reverse the polarities of the supply. So here suppose if I put 1 and here suppose if I put 0, then it may move in one particular direction. It may be positive, it may be forward or it may be reverse, but it will be in one direction. But if I reverse the supply, if I put it here 0 and if I put 1 over here, so that these pins will get previously which here they it must be getting 1 and 0 over here, so it must be moving in one direction. Now it is getting 0 and 1, so it will move in another direction. So our job is to supply this particular status to motor through microcontroller, and then we will provide some delay so that for a particular period it will move in one direction. Then after that delay we will change the status of this particular pins and we will again provide some delay and it will move in reverse direction. So, and this will continue so that the direction of DC motor will keep on changing. So what we have done, because we have used port 1, so on port 1, what status we are taking? We are taking FE. Now we all know that what FE stands for. FE means all these pins are 111 except port 1.0 pin, which is 0 with the status of FE. This is your FE. It indicates that for this particular hardware, we are giving one logic 1 to port pin 1.1 and logic 0 to port pin 1.0. Now with this condition, motor will start moving in one direction. Now here we have given VSS plus 12 volt, that means it indicates that the DC motor supply is 12 volt. We have provided one delay. You may write any delay of your choice, and this will be that one direction movement will be for this particular delay. We have already covered the programming of writing of this delay programs, but still for your reference it is once again given over here. After this delay, what we are doing, we have to reverse this conditions. Instead of 1.11, it should be 0 now, and instead of 1.0, it should 1 previously which was 0, it should be 1. So to reverse these polarities, you may take again move P1 and comma and whatever may be the word status, you can do that. But now here what we are doing, we are efficiently using the use of XORing. You all know that what is XOR is doing when your inputs are 0, 0, output is 0. When your inputs are 0, 1, output is 1. When your inputs are 1, 0, output is 1. And when your inputs are 1, 1, output is 0. So we are using the characteristics of this particular truth table. 1 1, it will make output as 0. So what we are doing, we are XORing the contents of port 1 with FF. Now this particular XORing previously, which was FE, now this is XORed with FF. So that is FE is XORed with FF. So now what is the next status? The new status in P1 will be, this will become, as per the truth table of XOR, this will become 1. As per the truth table of XOR, this will become 0. And this all will become 0. As such, we are not interested in these pins, whatever may be the status of these pins, we are not bothered. So what was our purpose? We have achieved that. The initial condition of 1 0 was now has been changed to 0 1. So now port 1 pins will be having the status of 0 1. So motor will start, previously it was 1 0, now it is 0 1. So previously it was moving in one direction, now it will move in another direction. Now what is the next instruction? The next instruction is S jump to DC loop. What is a DC loop? DC loop, where it is going to again calling the delay. So for one particular delay, it is moving in one direction, and for another for the same delay, it is moving in another direction. So it will go in DC loop. As soon as the delay gets over, again what is the instruction? XORing with FF. So now you are XORing this status with FF. Are you getting? So when I XOR this status with FF, what becomes? This will become, the one which was 1, this will become 0. Now this is becoming 0, this is becoming 1. So again we are at the first condition. This is our second. So now we again have gained the first condition. So now with this particular delay, again the motor will move in, will change the direction of the movement, which was in 2. It will be reverse 1 and it will move in another direction. Again the same situation will occur. Now how to change this delay? We have already seen the delay programs, but still for your reference, just I am repeating it because the program is very short and you should understand the concept of direction control. So what we have done, we have taken one register where we have taken some count into it. We have taken another register at R6. We have taken some count. Well, let's say it is 0 0. You may take any count depending upon the delay required. Then you have taken another register, and here also you have taken one count. So this is count 1, count 2, count 3. Now what we are doing? We are decrementing. What is D Gen Z is doing? D Gen Z will first decrement register R5 by 1. Decrementing by 1, then checking it whether it is 0 or not. And if it is not 0, then where it is moving to this particular location. Now what is there in our R5 register? R5 register is containing 0 0. So first it will not check for 0. First it will decrement by 1. So when we decrement 0 0 by 1, what will happen? When we decrement 0 0 by 1, it becomes FF by generating a borrow, which will set the carry flag. So it becomes FF, and now it will check for the condition. FF is not 0. So where it is going? It is going to the delay 3. Delay 3 is the very same instruction. So this will happen till R5 goes to 0 0. Once, that means it will be executed for FF times. Once R5 is completely 0, then we are going for decrementing the contents of R6 register. Now what is R6 register is containing? R6 register is also containing 0 0. So it will first decrement it by 1. So it will become FF, and it will check whether it is 0 or not. If it is not 0, it will go to the instruction delay 2. So now again R5 is reloaded with 0 0, and now again this will happen for FF times. So this FF times decrementing loop will be continued for FF times decrementing loop with the help of R6. And once both the registers are 0, 0, then once R7 is decremented by 1. You all know this program, and because it is a subroutine A called delay. Delay is a subroutine, so your ending instruction must be RET, written from subroutine. So you can write any type of delay programs. Suppose if I want to have, so we have covered the direction control of DC motor because it is having two polarities, positive, negative. So you can reverse the supply and the motor will change the direction of its rotation. But if you talk about the speed control of the DC motor, then what is the simple technique of this changing the speed of the DC motor? What we do, we have here supply voltage, we connect the DC motor to one polarity of this, and through another we put the rheostat or variable potentiometer, or which is also called as variable resistance. So by moving this wiper, by moving this particular end, you adjust the value of resistance, and accordingly the supply given, the current flowing through this DC motor, the supply given to this DC motor is varying, and hence its speed will vary. So by changing the input supply, you are changing the speed of this particular DC motor. But if you want to do this with the help of microcontroller or with the help of D2A converter, you must have studied PWM, pulse width modulated waveform. What is pulse width modulated waveform? This T is not going to change, and here it is how we call this is 50% duty cycle. You all know that what is duty cycle? Duty cycle is on time divided by the total time. So if your on time and off time both are equal, let's say this is x and this is x, so x divided by 2x, that is half. So half means it is 50% duty cycle. So you can provide the positive with 50% of this timing and negative with 50% of this timing. Now if you want to change the duty cycle, let's say this may be 70%. So 70% means your on time is having more timing compared to your off timing. But this T is not going to change. T will remain same. So this is 70% duty cycle. Here the positive supply is getting for more time and negative supply is being given for the less time. Now suppose if you take this, maybe this may be 25% or 20% duty cycle. So here what you have? You have less timing for positive supply and more timing for negative supply. Again this T is not going to change. So to change the speed control of DC motor, if we apply 50% duty cycle, that is on time, positive supply is for some period and negative supply is for the same period, then the motor will get the 50%, the motor will move with one particular speed. If we give more positive supply to this and less negative supply, the motor still will move faster. If we give less positive supply and more negative supply, that means stoppage is for more time, the speed of the motor will going to be reduced. So we will see in next session that how to control the speed motor with the help of 8051 microcontroller. Now stay safe, be at home, enjoy your learning with microcontroller, and don't come out of your house. Do all the exercises whatever we have given. Last time also I have shared some videos of NPTEL Swayam courses. Go through that also. Some assignments I have given in those particular PPTs. You have to do those assignments also. Staying at home, enjoy your learning, and stay connected with this particular sessions, videos which we will be continuing, which we will continue our syllabus, covering of the syllabus, covering of the curriculum with this type of homework. Now, here whatever I have given you, the very first assignment, don't forget to do that assignment because you have now plenty of time. The very first assignment was on, you have to develop the project, whatever you are learning on with 8051, whatever interfacing we have done with timer counter, whatever interfacing we have done with DAC, ADC, and now we are continuing with motor interfacing, etc. We'll be continuing with serial communication interfacing. There are so many interfacing. We have to cover keyboard interfacing, display interfacing, but you keep a track of this and you have to develop one project individually. This was our first assignment which you have to submit at the last. And there is also, I have already explained you that there is no restriction that you must use 8051 microcontroller. You can use, because now you are having the base of 8051 microcontroller, you can use any other microcontrollers, Arduino controllers, PIC microcontrollers. You can design any toys for the purpose of playing games, etc. with the help of 8051 microcontroller or any other microcontrollers. So goodbye then. We'll meet in another session.